Branches. Branches are like, I'm trying to fill in the following sentences. Branches are like blank. The first time you encounter them, they seem intimidating and hard to understand. But once you start using them, you can't imagine how you would live without them. And I don't know what a good fill in the blank would be. A car, an electric toothbrush, I don't know. But anyway, so what's a branch? A branch is basically a way that you can have multiple versions of the code living in the same repo, worked on by the same team, but which for various reasons you need to, at least for a while or temporarily, keep those versions separate. And the terminology that Git uses for this is the sort of default branch that exists when you create a new repo is always called master. If you came from the world of Subversion, that's very confusing because Subversion uses the term master in a very different way. They use it to mean the repo, which is the one true golden copy. And as we know, in Git, there is no such thing as the one true golden copy, unless the team decides by convention to agree, which is what we recommend. So basically, the idea is that you want to be able to have code development proceeding simultaneously in ways that under normal circumstances might cause conflicts if you try to merge them, but you've got a reason to do it. So when you create a new branch, which is very, very cheap, and I'll show you some basic commands to do it, you can check out, meaning you can switch your notion of which is the current branch that you're working on. Every branch has its own commit history, so when I commit things on one branch, that has no effect on those same files but living in another branch. I can decide at some point that I'm going to merge a branch back into the master, and conceptually, the merge process that happens there really is no different than the one that happens when you need to merge commits from master into your own repo, right? So you already understand the concept of somebody else made some commits, and when I do a git pull, those commits are going to be applied to my copy of the repo. Well, a branch is the same thing, right? On a branch, you've made some changes to some files that are absent from the master branch. So the concept of merging that branch back into master uses exactly the same set of techniques. Although, as we'll see, most branches eventually die. They don't get merged back. They're used for things that you don't actually have to merge them back in the end. But a killer usage case for branches, especially in agile development for SaaS, is doing a branch per feature. And the problem that this solves is when you have a project that's stable. Remember, our philosophy with BDD and TDD is always have working code, right? You always want to have a code base that you could, in principle, you could deploy from. So how do you create new features without destabilizing your working code base? And the idea is that every time you're going to work on a new feature, you make a new branch just for that feature. And that may sound like it's overkill, but you'll find if you try creating branches that it takes roughly no time to create a branch, roughly no time to switch back and forth between them. And remember, programmers are optimists, right? We always think, this feature is so simple, I'm just going to make this two-line change to the file, and then everything will work. And we all know that it never turns out that way. So believe me when I say branches are your friend. You use this branch only for changes related to that feature, and you're strict about that, right? If you run into sort of, oh, this piece of code is ugly, let me just quickly fix it while I'm working on the new feature. Don't do that, right? Remember, we're optimists. We're going to get it wrong. We're going to screw something up. So this branch is only for the feature. And by the way, the other reason to have a branch really just truly and only for that one feature and nothing else is if the unthinkable happens, we create our feature branch, we eventually merge it back into master, and there's some reason it turns out we should not have done that, we know that if we back out the merge, which we know we can undo, the only effect of backing out the merge is to remove that feature. So if we had used a branch to do a new feature and also fix up some ugliness along the way, maybe the fixing up the ugliness was worth having in master, but rolling back the branch would undo it. So in a well-factored application, the idea is that one feature branch shouldn't have to touch that many parts of the app, so the number of commits necessary on the branch should be small. So this diagram is taken from the book, but it illustrates a couple of different scenarios here. In this top scenario, so the line that runs horizontally through the center here is the master. And we've got Amy deciding that she's going to make a branch off of this commit labeled A because she wants to work on a feature. Simultaneously, Bob and Dee are going to make other branches. So here, there's now 4 active branches total, including the master branch. And each branch has its own commit history. Amy decides that her branch is done. She tests her code. That gets merged back into master. And that means that when it's time for Dee to merge back into master, she may or may not have some conflicts, right? Because if there was any overlap between files that Dee was touching and files that Amy was touching, when Dee tries to actually merge her changes back in, there may be some files that need manual fix-up. Poor Bob was working on his feature, and his feature is just not going to pan out. So that's fine. You just let the branch die. It never gets merged back. And there's an anecdote that I'll tell about this momentarily that goes with the legacy code section, but this is a better time to tell it. OK, so the mechanics. How do you work with branches? To create a new branch and switch to it, you can either say git branch and then git checkout. There's always a notion of the current branch. So whenever you're editing in your repository, when you're making changes to a file, you're making changes to that file as it exists on some particular branch. And if you look in the book, there's a really neat hack that I copied from someplace on the internet that makes your shell prompt tell you which branch you're currently in. As an example, when I do the live demos in this class, I have a version of Rotten Potatoes that has like 12 different branches. And each branch is there to do a demo related to one specific feature as we sort of develop the app. So you do whatever you have to do on your branch. You can push your branch to the origin. You don't have to, right? You could do all your work locally on your branch, merge the branch locally, push master, and then the remote will never have even known that that branch existed. I find that it's good to push the branch to the remote because then you have a backup of it in case anything goes wrong. It doesn't really cost you anything. Now, so far we've just been saying git pull, git push. In fact, those are shorthands where you're assuming that Git can infer the name of the remote and the name of the branch. Origin is the canonical name for the remote that you set up on GitHub. And by default, if you don't include the branch name, it's assumed to be master. So when you say git push by itself, you're really saying git push origin master. Here's an example of git push origin cool new feature branch that I just made. And what will happen is that will be created as what's called a tracking branch on master, right? Or on the remote repo. That means the remote repo now creates a new branch that is going to follow any changes you commit to your local branch. But again, totally separate from anything happening on master, right? You're still in your old little development world. Once you're happy with what's in your branch, you can switch back to the master with git checkout master. You merge, and there may be some manual fix-ups that you have to do. You already know that if the merge goes horribly awry, you can use git reset to get back out of it. In a moment, we'll talk about git rebase, which is a thing that could be very useful if you do something naughty, which is to allow your branch to drift very far out of touch with master. This flow works really great if the average lifetime of a branch is short, like maybe order of a few days or something like that. But if you have a branch that lives for weeks, during the time that you're developing stuff on your branch, probably things are happening on master as well. And by the time you go to merge your branch back in, there may be so much that has changed in master that trying to do that manual merge becomes a mess. So we'll talk about what you can do with that. So what happens if your feature branches aren't short-lived? Well, you can do a git rebase, which you can sort of think of as an opposite of the merge. And the way to think of rebase is going back to our diagram with the various branches here. In our simple example, there hadn't been any new commits to master during the time Amy was working on her branch, but by the time D is getting ready to check her branch back in, there has been one commit. So as I said, that means there's a possibility that when this merge happens back to master, there might be some conflicts that have to be manually resolved because of commit C that was not present in D's development branch. One thing that D might have been able to do is before doing this merge, she could ask Git to rebase against C. So what does that mean? When she created her branch, it was basically a snapshot of what the world looked like at commit point A, and then she started making changes based on that. Rebase means pretend that my branch should have been based on a snapshot of what the world looked like at commit point C, right? And the effect of that is if there's a merge conflict that would have resulted by doing this merge at point D, it'll be exposed when she tries to do the rebase. So a very common thing that you'll do is if you're working on somebody else's repo, you'll do a branch, you'll make all of your changes, but before trying to merge, you will rebase against the latest version of their master, because that way you essentially are getting a preview of all the merge conflicts that could go wrong when you actually do the merge back to master. You get a chance to do a commit locally that will fix those and make them not happen, and then you say, okay, I'm ready for you to take my branch and merge it into your master. I have done a rebase, so I know that you're not going to get any manual conflicts when you do that. Rebase is a really neat feature once you learn to use it. There's also git cherry pick. Cherry pick is used to merge only specific commits as opposed to everything on a branch. And a reason that you might want to use this comes from two different scenarios that are very common branch usages in Agile. One of them is branch per release, and the other one is branch per feature, which we already saw. So let's talk about branch per release. A lot of Agile projects, by the way, don't even bother to do branches per release. The way they release software is it's always assumed that master is stable. At any moment in time, you can redeploy from master and the world should not explode. But in some projects where release manager is more complicated, an alternate strategy is branch per release. And this is where cherry picking can be useful. So what happens here? Here's a project whose master branch is along the top. And at commit A, we're ready to deploy the project. So what some organizations will do is that they'll create a branch at this point. The sole function of this branch is to be the reference for what got released. Why would you want to do that? Well, one possibility is, suppose after we release, we find a bug, right? There's no quicker way to find a bug than to release and have your users hammer on something, believe me. So your users find the bug. The team that is in charge of the deployed version can immediately apply a fix right on the release branch. They can redeploy from that branch, and this is all separate from master, right? So it doesn't interfere with other development. And if it turns out that the bug fix also would be applicable to master, you can decide to cherry pick just that commit and merge that change back into master. And similarly, if the development team looking at the master branch realizes there's a gaping security hole they forgot to patch before releasing, they could fix that security hole with a commit at D, and the release team can selectively merge just that commit into the release branch and redeploy from there. So it's basically a way to give a release a little bit of a life of its own, so that bug fixes from the release can be selectively merged back to master, and critical fixes that occur in master can also be selectively merged into the release. So Git cherry pick is what gives you the ability to say, I don't want that whole branch, but I want just the changes introduced by that commit. This is an example, by the way, of something you don't see that often. It's called a Criss-Cross Merge. In most branching strategies for small teams, merges tend to go in one direction, right? You'll branch off of master, you'll merge back into master, but it's rare that once you've got a branch going, you're sending changes from master into the branch. So this is an example where it could go either way, and again, it's motivated in this case by the release per, or branch per feature or branch per release scenario. Branching versus forking. You already know that you can fork an entire copy of the repo on GitHub. That's because Git is based on this collaboration model that says if everybody in the world who wanted to play with your code had to get your permission, that wouldn't scale. So we'll just let anybody fork your entire repo, and then even though they can't push to your repo, they can do everything we just described and selectively make a pull request saying, here's a piece of code that I developed on a branch. It's tested. I rebased it against your latest master. It is safe to merge. Please accept my code. So this is the sort of share-alike model of the world that Git was designed to support really well. So if you don't have push privileges on a repo, this is kind of a way that you can contribute to a project. You can fork the repo. You can do whatever you want on your own branch, so it's clean. Test the changes, rebase against their master, and then send the owner of the original repo a pull request on GitHub asking them to merge in your branch. And if you're a good citizen, you've done all the work so that the branch merge won't cause the world to explode. Pitfalls or Gitfalls. Stomping on changes after doing a merge. I hate when people do this, right? So somebody will do a merge, the merge will have some commits, and then they'll just copy a bunch of files over from a temporary area and splot everything that was on top of the merge. Don't do that. It makes you a bad citizen, right? It means you're not using version control properly. If there's conflicts, the conflicts are trying to tell you something, like talk to your team. Again, making simple changes directly on the master. Never, ever, ever change anything on master. Don't do it. Even if you don't intend to deploy from master, even if you're going to do release branches, let master be clean. Let it be the one safe port in the storm that when you're feeling like you've had a terrible day and you're the world's worst programmer, you can go back to master and say, I'm not so bad. Look at this. This code's good. So always do your changes on a branch. I know it's very, very tempting to think this change is going to be simple, but they never are. That you do a change, and that means, oh, I got to change this other thing. Oh, but that made this test break. Oh, but if this test is broken, I got to refactor my fixtures. No. Do it on a branch, and you're free of all that nightmare. Keep master clean. And again, as I've said many times, I would not be telling you to do stuff if A, I had not done it myself, and B, I had not also felt the excruciating pain from not following my own advice. I'm telling you, don't let the blood harm your keyboard. Don't do anything on master. OK, so here is a question about branches. If you've got separate subteams and they're working on, you've got a team for release bug fixes, and you've got a team that's just working on a new feature or features, which of these approaches would you or should you be using? Branch per release, branch per feature, both of them, or depending on the team, probably any of them would work.